Okay, the Unit 2 semester review packet on YouTube. Remember, you should not be copying this like your regular notes that you've been doing all year. You should be doing problems first and using this only when you are stuck or to check your answers. So, first unit up is Unit 7. And we begin with a review of domain and range. Okay, so looking at our first example here, domain is a set of x values, alright, that are covered by the graph, the image of the graph. Alright, and the way we establish a domain is we look for a left boundary and then we look for a right boundary. Okay, in this case, we have an arrow which says this thing will go left forever, and we have an arrow up here which says this will go right forever. And because there's no left bound or right bound, this is all real numbers. All real numbers. Okay? Let's look at the range. Now the range we're going to read bottom up. Alright, so when I look again at this arrow, that tells me it's going down forever. And when I look up here at this one, that tells me it's going up forever. And because there's no bottom or top, once again we have all real numbers as our range. Okay? Moving on to number 2. Again, the domain from left to right. That arrow means it goes up and to the left forever. This arrow means it goes up and to the right forever. There's no left end. There's no right end. Once again, our domain in this problem is all real numbers. My range, as I work bottom up, I do find a bottom, alright, right here at -2. Alright, but there is no top. So what I do is I put my y value, or my y, alright, I put that bottom number, and then I have to decide a couple things here. Do we actually touch -2? And the answer is yes here. Okay, and then are we above it or below it? Okay, we're clearly above with our image. Alright, that makes this greater than or equal to. If it was below, if it went like this, we would do less than or equal to. Alright, and then number 3, now we have just points on our graph. Okay, when we have points on our graph with no line connecting them, alright, we are reading just the values of the ordered pairs. Alright, we don't have to set up inequalities or a statement like all real numbers. Alright, instead we're just going to read the values. So I see a point at -3. I see one at -2. I see 2 of them at 1, but I only list that once. And then I see one at 4. So I have a set -3, -2, 1, and 4. And then I read bottom up for my range. Alright, the first one I see is at -4. Then I come up to -2. Then there's one at 0. There's one at 3 and at 5. Remember, I'm looking at the y value. So when I say there's one at 0, this is the point 4, 0. That's the x value. This is the y. So that's where that 0 came from right there. Alright? So that's a review of domain and range. Alright, up next. Alright, finding function values when we're given an input. Going to work like this. Alright, in example 4, we want to find the value when f is -2. So we're going to say f of -2 equals, and wherever I see an x, I'm going to place a -2 in. Alright, now it's just as simple as simplifying. Alright, multiplication first, and then we could do our subtraction. So f of -2 is equal to -11. So again, the way I'm reading this and why function notation works, or how it works, is this tells us we inputted the number -2 and what came out was -11. Alright, it allows us to see both what went in and what comes out. Alright, looking at f. Again, we're going to say, let's find the value of this function when x is 3. So wherever I see an x, I'm going to use my parentheses and the number 3 to substitute. And then I use order of operations to simplify. So squaring would be 9. This is basically squaring as well. So I got another 9 and then 2. Alright. From here, 9 minus 9, 0, which leaves me with a -2 left over. So the function value at 3 is -2. Alright, moving on to 6. Same situation. Alright, we're finding negative 2 once again. And it's the same function as the previous one. Alright, just a different input. Again, use parentheses as you do this. A little bit out there. Alright. Once again, we're going to simplify order of operations. A negative squared is going to become positive. So negative 2 times negative 2 is positive 4. Negative 3 times negative 2, that's positive 6. And I'm going to drop my subtraction of 2 down. Alright, up next, addition and subtraction. We go from left to right. So I do the addition first in this case. And finally, I could do that last subtraction here and get 8. So the function value at negative 2 is 8. Alright. Last thing for the Unit 7 video, alright, deals with functions, whether or not something is or is not a function. Alright, and we have a number of different ways of looking at this. Okay, we did some mapping, we looked at ordered pairs, and we looked at graphs. Okay, so with that being said, when I go to map, alright, what this is saying is 2 maps to 3, that's a point, 2 comma 3. Alright, we say 4 goes to 5, and it goes to 7. And then the last one, 6 goes to 9. Okay, so those are ordered pairs. Now, determining if this is a function or not, alright, we're looking at the x values and saying, do any of these repeat? Because if the x values repeat, it's not a function. Alright, and you'll notice right here, we have the number 4 twice. Alright, and you see that in the mapping when this thing gets split. That's known as 1 to many, or 1 to 2 in this case, with mapping instead of 1 to 1. We want 1 to 1, meaning this goes from 1 to 1. But as soon as we get one number that breaks the rule, is this a function? No. Why? We could say because 4 repeats in the domain. You're not allowed repeats in the domain. Alright? So with that being said, number 8 should be pretty simple because we use the same idea over here. I'm specifically looking at the x values, there, and there, and seeing do any of those numbers repeat. Alright, so I have negative 1, 0, negative 2, and 8. None of those are repeaters. So yes, this is a function. Alright, why or why not? Because there are no repeat values in the domain. Alright, now you'll notice if you look at the range, negative 1 does repeat, but that does not matter. It's only the domain. Okay, so keep your eyes on the domain. Alright, and finally, alright, we're looking at this graph here, and when we look at graphs, we learn something called the vertical line test, which basically says if you could take a vertical line, like that I just drew on the side, okay, and slide it across your image. Oops, sorry, I pressed the wrong button. Now I got a circle there. Let me go back. Sorry about that. Alright, so let me get my selector again. Alright, so if I take this and I slide it across, notice I'm only hitting 1 point on that line the whole way. 1, 1, 1, 1, 1, 1, 1, 1 the whole way. Okay, when that happens, we are said to have passed the vertical line test, which yes makes this a function. Alright, so explain below or show why or why not the graph, why or why not on the graph. So you could do the vertical line test, alright, or we could just say it passes the vertical line test. Okay, let me see if there's anything else I need to worry about. Oh, there is domain and range down here. I almost didn't see that on my video, alright, or on my screen. So let me very quickly answer the bottom here, domain and range. Alright, again, domain and range is just a list of the x values. So in number 7, we have 2, 4, and 6. In number 8, I have negative 1, 0, negative 2, and 8. Alright, for my range, on number 7, I have 3, 5, 7, and 9. And for my range here, I have -1, 7. Remember, we don't repeat, so I'm not going to write that -1 again. Alright, I'm going to skip it and go to -3. Alright, there we go. Okay, so that's your review of Unit 7. Again, all the videos are up for Unit 7, so if there's an idea that you did not understand as I went through it, you might want to rewatch one of those videos. Good luck on your final.